Philippine archipelago is surrounded by several volcanic belts, which all have a heavy concentration of volcanic centers. The Central Luzon Belt, for instance, is marked by the Zambales and Mindoro ranges and the volcanic region that includes Taal Volcano, Mount Makiling, and Mount Manahaw in southern Luzon. There are more than 200 volcanoes in the Philippines. Of this number, 21 are considered active, meaning they have erupted one time or another during the historic times. Mayon, Taal, Hibok-Hibok, Bulusan, and Canlaon are considered the most active volcanoes to date due to the frequency of their eruption. Mount Pinatubo is an addition to this list now. Mount Pinatubo, the home of the Aitas, is a part of the chain of volcanoes bordering the western side of Luzon in the central portion of the Zambales Range that also includes Mount Natib and Mount Mariveles. Before its eruption, Mount Pinatubo had an elevation of 1,745 meters above sea level, towering above the provinces of Zambales, Pampanga, and Tarlac. For hundreds of years, the Aitas have considered Mount Pinatubo their own, as the Aboriginal tribal community depended on its slopes and rivers for their food, water, and livelihood for as long as they can remember. To them, the volcano is also their deity they call Apo Malyari. Then, sometime in March 1991, the Aitas started noticing some unusual signs in the mountain they revere. The mountain rumbled, and the frightening sounds drove the animals and fowls down its slopes. There, Apo Malyari has become angry, they said. On April 2, 1991, a hydrothermal explosion occurred at Mount Pinatubo. Steam columns about 500 to 800 meters high started coming out of some openings called vents on the slopes of the volcano. This event was reported to the Philippine Institute of Volcanology and Seismology, or PHIVOLCS, by Sister Emma of the Lakas Foundation. In response, PHIVOLCS immediately dispatched a Quick Response Team, or QRT, on April 4, 1991, to conduct an aerial survey. Five steaming vents were located on the northwest summit of Mount Pinatubo. The next day, the QRT set up its first temporary seismic station at Sitio Yamut, Barangay Villar in Botolan. Within a 24-hour monitoring period, the QRT recorded a total of 223 high-frequency volcanic earthquakes, 4 of which were felt and were accompanied by rumbling sounds, indicating active fracturing of the rocks and movement of ground fissures or cracks due to pressure exerted by the steam escaping from underneath the volcano. PHIVOLCS therefore raised Alert Level 1 at Mount Pinatubo, meaning the volcano was already exhibiting abnormal activity, but its eruption was not yet imminent. On April 9, 1991, PHIVOLCS declared a 10-kilometer radius danger zone at Mount Pinatubo. People were advised not to venture within the danger zone. Within a few days, PHIVOLCS installed more seismic stations in Moraza, Magisgis, Burgos, and Nacolcol. Volcanologists of PHIVOLCS and the United States Geological Survey, or USGS, also installed at Mount Pinatubo a seismic telemetry network that relayed data on the volcanic activity to the Clark Air Base Volcano Observatory. From then on, the seismic stations recorded an average of 50 to 90 volcanic quakes in a day, increasing to 167 on May 11. After that date, the number of seismic events dropped, only to increase again on May 17, a day after raising Alert Level 2, meaning the volcano's condition at the time could eventually lead to an eruption, as there were already indications of magma intrusion. In between monitoring the seismic activity of Mount Pinatubo, the USGS scientists, led by Dr. Chris Newhall and PHIVOLCS volcanologists, also measured with the use of a correlation spectrometer, or COSPEC, the concentration of sulfur dioxide content of the steam plumes rising from the volcano. Their initial findings indicated that magma, the high-temperature molten material, was rising to the summit of the volcano. Magma, the scientists estimated, was already less than 5 kilometers beneath Mount Pinatubo. Ground deformation studies were also conducted simultaneously to determine if the volcano was swelling. By then, the hazard zonation maps indicating the maximum extents of prehistoric and historic pyroclastic flows, tephra faults, and lahars had been prepared by PHIVOLCS and USGS volcanologists and seismologists, and the Institute was able to anticipate the nature and magnitude of Mount Pinatubo's eruption and the areas to be endangered in the event a volcanic upheaval occurred. In a series of meetings, Dr. Raimundo S. Punongbayan, director of the Philippine Institute of Volcanology and Seismology, discussed with officials of the local government units and disaster coordinating councils the hazards posed by Mount Pinatubo. With the volcanic hazards map, Director Punongbayan pointed the areas to be affected by the raging volcano. Without being an alarmist, Director Punongbayan also told them of worst-case scenarios that could happen. That early, too, he advised them to be prepared. Meanwhile, Mount Pinatubo's condition continued to deteriorate. High-frequency volcanic earthquakes, some felt at varying intensities and accompanied by rumbling sounds, incessantly rocked the volcano. Its ash emission intensified. Ash-laden steam columns reached heights ranging from 800 to 1,500 meters above the active vents. The traces of volcanic ash that had already seared the lush vegetation close to the active vents kept increasing, scorching a growing area. On June 6, when the volcano showed a marked upsurge in seismicity and long-period volcanic tremors and phreatic explosions became more frequent, and other manifestations indicated that eruption was possible within 2 weeks, Alert Level 3 was raised. At that time, the amount of sulfur dioxide content of the ash-laden steam plumes suddenly decreased, and with the frequent occurrence of phreatic explosions, it meant that a growing mass of lava or molten material had already risen near the surface and had plugged the passage of volcanic gases. With the raising of Alert Level 3, villagers, mostly belonging to the Aita tribal community, were advised to totally evacuate the area, particularly the northwest and west slopes of the volcano, where the sulfur stench was stronger and the ash falls were heavier. More ash ejections, accompanied by frightening rumbling sounds, followed. On June 7, the seismic monitoring network of PHIVOLCS and USGS detected intense unrest going on at Mount Pinatubo. as more harmonic tremors or long-period earthquakes, as well as low-frequency volcanic quakes, were recorded in all seismographs. That day, alert level 4, meaning eruption is possible within 24 hours, was raised and the 20-kilometer radius danger zone was declared. That day, massive evacuation was conducted by the provincial government of Zambales and its local government units in all the sitios and barangays located within the 20-kilometer radius danger zone. In the afternoon of June 8, the monitoring network at Clark Air Base detected the presence near the central vent of the dome, a 30-meter high formation of highly viscous lava, which solidifies upon surfacing at the summit. The next day, June 9, at exactly 2:55 p.m., Mount Pinatubo began its eruption episodes. Pyroclastic flows, masses of scorching ash, gas and fragmented rocks with a temperature of 1,000 degrees Celsius and traveling at 60 or more kilometers per hour, rolled some 4 to 5 kilometers down the western slopes following the gully of the Maraunot River. That day, PHIVOLCS issued alert level 5. Eruption was in progress. That very same day, the American servicemen, their families, and dependents were ordered to leave Clark Air Base, only some 16 kilometers away from the volcano. They evacuated eventually to their home country, thousands of miles away from the fury of Mount Pinatubo. Volcanologists and seismologists of PHIVOLCS and USGS continued their close monitoring as Mount Pinatubo's seismic activity heightened. Harmonic tremors or long-period quakes became more constant as magma began rising from its chamber below toward the surface of the volcano. The geoscientists knew that Mount Pinatubo was just preparing for another eruption of pyroclastic flows. Meanwhile, Mount Pinatubo's continuous ash and steam ejection began dumping on all the rivers radiating from the volcano, more ash, increasing the potential for lahars. On June 12, at exactly 8:51 a.m., Mount Pinatubo erupted anew. A big explosion sent a huge, mushroom-shaped cloud that rose to 20 kilometers above the active vent. Ash, pumice, and other large volcanic fragments showered on the western, northwestern, and southwestern sides of the volcano. Life-threatening pyroclastic flows cascaded down the Morelia, Maraunot, O'Donnell, and Sacobia rivers. Heavy ash falls affected the municipalities of Botolan, Cabangan, San Felipe, San Antonio, San Narciso, San Marcelino, and Castillejos. Iba and Subic also experienced traces of ashfall. Before midnight that night, a second series of strong explosions occurred, and its 25-kilometer-high ash-laden steam clouds brought more ash and larger volcanic fragments to the affected areas. Airfall particles were also experienced in places 22 kilometers away from the volcano. On June 13, another violent eruption occurred at 8:41 a.m. Big explosions sent ash clouds some 25 kilometers high above the active vents. Pyroclastic flows cascaded down the Moraza, Maraunot, Morelia, and O'Donnell rivers. Friday, June 14 at 1:09 p.m., the fourth major eruption episode began with a series of strong explosions, continuous volcanic earthquakes, and ejections of voluminous ash and other fragmental volcanic materials. Fearing a calderogenic eruption may occur, PHIVOLCS declared a 40-kilometer radius danger zone. The explosions continued until 2 p.m., and within minutes, the Zambales towns of San Marcelino, San Antonio, and San Narciso were shrouded by ashfall. As predicted by PHIVOLCS, the June 14 eruption episode lasted long. It continued till the next day while Tropical Storm Diding raged. June 15. At about 7 a.m., the seismographs at Clark Air Base suddenly steadied into a straight line after making some jagged markings. No choked. At 7:30 a.m., it erupted again, followed by a succession of eruptions accompanied by strong earthquakes, incandescent pyroclastic flows, and voluminous ash emissions that formed columns as high as 40 kilometers. That afternoon, Mount Pinatubo's summit disappeared, reducing the volcano's height to about 1,400 meters. Due to the long eruption period of volcanic earthquakes and ash ejections, the summit collapsed in on itself, then burned and spewed in one big whoosh. A new 3-kilometer wide crater now lies in its place. This is a computer-generated graphic animation of how the crater was formed. That day, as Mount Pinatubo was erupting violently while Tropical Storm Diding raged, an unusual darkness descended over a wide area, turning day into night. With the darkness came the rains of ash and sand, and within minutes, fine volcanic dust blanketed large areas of Central Luzon and Metro Manila. The heavy ashfall buried large areas of agricultural land, smothered crops and other plants, clogged and damaged utility facilities, and caused roof collapse of houses, schools, and other public and private buildings. Mount Pinatubo's ashfalls, experienced as far as the Ilocos provinces in the north and Palawan in the south, also crossed the South China Sea and reached Thailand and Cambodia. By now, traces of Mount Pinatubo's ash and fine volcanic dust have already circled the Earth at least once. The June 14 to 15 geologic upheaval of Mount Pinatubo has transformed not only the volcano itself, but the entire topography and landscape around it, and all the areas affected by the geologic upheaval. The transformation is going on even now. The danger posed by Mount Pinatubo is far from over. In fact, the dangers from the principal hazards associated with its June 14 to 15 eruption have just begun. The large volume of volcanic materials, now estimated to be about 7 cubic kilometers, ejected as pyroclastic flows, ash, pumice, and other volcanic debris, had become the source of life-threatening hazards that will be present for months, years, and maybe for decades. The most destructive of these hazards are lahars, the rain-triggered volcanic debris and water mass flow that can cascade downslope fast and bury low-lying areas with boulders, sand, and mud. Destroy houses, buildings, and infrastructures. Clog drainage channels, raise riverbeds, and cause flooding of extensive areas. Lahars will continue to sow terror and wreak damage for as long as there are pyroclastic materials, ash, pumice, and other debris deposited on the slopes and gullies of Mount Pinatubo and on the rivers whose headwaters emanate from the volcano. Indeed, the danger of Mount Pinatubo is far from over. Even now, the toll of the geologic upheaval that is considered one of the world's biggest eruptions this century continues to rise. The number of lives lost and of people who have been displaced by the destruction of their homes and the damage to public and private infrastructure, properties, agricultural land and crops, and others keep increasing. The summation cannot be done yet.